Okay, this is a past leaving question on Stiochiometry, Chemistry Higher Level 2017, question 11a. And we're told that some of the blue pigment azurite used by an artist in a picture painted in 1600 has changed over the years into green malachite, according to the following balanced chemical equation. We can see that we've got our azurite here, which is blue, and that's a solid, plus our water, which is a liquid, goes to our malachite, which is green and also a solid, plus carbon dioxide, and we're told that is a gas. Analysis shows that only copper containing pigments in the painting are azurite and malachite, and that the picture now contains 3.81 grams of copper. First part of the question: what mass of pure azurite contains 3.81 grams of copper? So we're looking for the mass of azurite for this question. Now, there's a process to solving this question, and it looks a bit complicated. There's a couple of steps, but it's broken down step by step here. We're given the number of grams of copper, and we can use the relative atomic mass of copper to find the number of moles of copper. Once we have the number of moles of copper, we can use our balanced chemical equation to get our molar ratio of copper to azurite. When we've got that ratio, then we can work out the number of moles of azurite that we have. When we've got the number of moles of azurite, we can use the relative molecular mass of azurite to calculate the number of grams of azurite, and this is going to be our final answer here. So it looks a bit complicated. There's a good few steps here, but when it's broken down simply step by step, the problem isn't actually too bad. Okay, so the first part. We're told that we have got a mass of 3.81 grams of copper, and we're looking for the number of grams of azurite that will be contained in that. So we've got this step. Now we're going to use the relative atomic mass of copper to find the number of moles of copper that we have. So let's do that now. If we go to our periodic table, we'll find that the relative atomic mass of copper is 63.5 grams per mole. This is telling us that in 63.5 grams, that's equal to 1 mole. Well, we've got 3.81 grams, so we're going to try to figure out what 3.81 grams, how many moles would that be? So we're going to divide both sides by 63.5 first, and that's going to give us what the number of moles for 1 gram is equal to, and that's equal to 1 divided by 63 moles. Now we're going to multiply it by the number of grams that we're interested in, 3.81. So 3.81 grams is going to equal 0.06 moles of copper. So now we can see what we've just done here. We've used the relative atomic mass of copper to find the number of moles of copper. Now the next step is we're going to use our molar ratio from our balanced chemical equation to see what's the ratio of copper to azurite. Okay, so we're actually only going to be looking at the azurite molecule here. And we can see that in one molecule of azurite, just this molecule, there are 3 atoms of copper. So that means in 3 atoms of copper, it makes up 1 molecule. So that gives us a ratio of 3 is to 1. So we've got our copper and we've got our azurite. We know that 3 atoms of copper is equal to 1 molecule of azurite. Well, we could also say 3 dozen copper atoms would be 3 dozen molecules of azurite. And similarly enough, the way that a mole is just like a dozen, we can say that 3 moles of copper is equal to, 1 dozen back here, 3 moles of copper is equal to 1 mole of azurite. Now we've worked out that we have got 0.06 moles of copper. How many moles of azurite would we have? Well, we're going to divide by 3 because it's a ratio of 3 is to 1, and we're going to have 0.02 moles of azurite. Okay, so going back to this, our process here, we've used our molar ratio to figure out how many moles of azurite we have. We know now that we've got 0.02 moles of azurite. Now we need to use our relative molecular mass of azurite to find the number of grams of azurite that we have. So we have got 0.02 moles of azurite. We need to use our relative molecular mass of azurite now. Now if we look at our azurite molecule, we can see that we've got 3 copper atoms. So we've got times 3 Cu atoms. We've got carbon here, but it's times 2 because of our brackets. Times 2 carbon. We've got 3 oxygens here, but it's going to be 3 times 2 because of our brackets here. So we've got oxygen is going to be 3 times 2 is times 6. And we've got another oxygen here, which is times 2. And hydrogen times 2 as well. Now we go to our periodic table, we find our relative atomic masses for each of these. We can see that for copper it's 63.5 grams per mole. For carbon it's 12, oxygen it's 16, 16 again for oxygen, and just 1 for hydrogen. Now we're going to multiply these by the number of atoms that we have in each. So we've got 3 coppers, 2 carbons, 6 oxygens, and another 2 oxygens, and 2 hydrogens. And this is going to equal 190.5 grams per mole, 24 grams per mole for the carbon, 96 for our oxygen, plus another 32 grams per mole for our oxygen, plus our 2. So when we add all of these together, we have got a relative molecular mass of azurite, which is equal to 344.5 grams per mole. And this is a really useful piece of information, because now we have our relative molecular mass of azurite Now we can find the number of grams of azurite that we need. And that's our final answer. Okay. And also, something I forgot to mention, it's incredibly important that you show your workings on how you added this up here. If you don't show your workings and you make one small mistake, you get no marks for this. So show your workings. Okay, so what this is telling us here is that 1 mole of azurite is equal to 344.5 grams of azurite. Well, we don't have 1 mole. We've got 0.02 moles of azurite. So if we multiply both sides by 0.02, we'll have 0.02 moles of azurite is equal to 344.5 grams times 0.02 is equal to 6.89 grams of azurite. And that there is our final answer for part 1. Now we'll go back to our question. We're not done just yet. Part 2. We're asked to calculate the maximum mass of malachite that will eventually be formed from this mass of azurite. So the maximum mass of malachite. So here's the big picture again. What's going to happen? Well, from the last question we have the number of moles of azurite. We can use our molar ratio from our balanced chemical equation to find the number of moles of malachite. Once we have the number of moles of malachite, we can work out our relative molecular mass of malachite to find the number of grams of malachite. So it seems a bit complicated. There's a couple of steps involved, but each step itself individually is actually quite simple. So let's get stuck into this. So we know that we've got 0.02 moles of azurite. We worked that out from part 1. So this is our starting point. We have the number of moles of azurite. Now we're going to look at our molar ratio from our balanced chemical equation. And we can see here that we've got a molar ratio of azurite to malachite of 2:3. 2 moles of azurite is to 3 moles of malachite. So that's our molar ratio. So from our azurite is 2 to our malachite is 3. So if we've got 0.02 moles of azurite, well, it stands to reason, if our ratio is 2:3, we're going to have 0.03 moles of malachite. So we're going to have 0.03 moles of malachite. Okay, so where are we now? We have the number of moles of malachite. Now we need to work out our relative molecular mass of malachite and use this to find the number of grams. So next step, the relative molecular mass of malachite. So we can see here what our malachite molecule is made up of. It is made up of 2 copper atoms. So we've got times 2 copper. It's made up of 1 carbon atom times 1 for carbon. We've got 3 oxygens here times 3 for our oxygen. We've got another oxygen here, and that's times 2 because of our brackets here and the 2 outside it. So times 2 for another set of oxygens. And we've got our hydrogen here also times 2. Okay. So copper's, when we go to our periodic table, look up at the relative atomic mass of copper, and we can see it is 63.5 grams per mole. Carbon is 12, oxygen is 16, 16 again, and 1 for hydrogen. Times 2 for our copper, because we've got 2 of them, is 127, times 1 for our carbon. So that's just 12 times 3 for our oxygen here. That's 48 times another 2 is 32, and times 2 is 1. So when we add all of these up together, we will have the relative molecular mass of our malachite. So that is equal to 221 grams per mole. 221 grams per mole. So what this is telling us here is that 1 mole is equal to 221 grams. Well, we're not interested in 1 mole in this case. We're interested in 0.03 moles of malachite. So we're going to times both sides by 0.03, and we're going to have 0.03 moles is equal to 221 grams times 0.03 is equal to 6.63 grams of malachite. And that there is the final answer to that part. So we can see what we did there. We used our relative molecular mass of malachite to find the number of grams of malachite that we actually have here. Now, part 3 of this question. We're asked what is the volume measured at STP of carbon dioxide that will be released from the painting in the formation of this mass of malachite? Okay. So we're looking for a volume of carbon dioxide. And this is the workflow for this part of the question. We have the number of moles of azurite. We're going to look at our balanced chemical equation for our molar ratio of azurite to carbon dioxide, and that will give us the number of moles of carbon dioxide that we have. Then we're going to use the molar volume to calculate the volume of carbon dioxide that is present. And that's going to be our final answer there. Okay then. So we're looking for the volume of carbon dioxide. But we know that we have got 0.02 moles of azurite. We found that in part 1 of the question. Now if we look at our balanced chemical equation here, we've got a ratio of 2 moles of azurite is to 1 mole of carbon dioxide. So we've got a ratio of 2 is to 1. So we have got azurite is to carbon dioxide of 2 is to 1. So we've got 0.02 moles of azorite. How many moles of carbon dioxide are we going to have? Well, we're going to have half the number of moles of carbon dioxide. So this means that we're going to have 0.01 moles of CO2. Now, we need to use our formula and tables booklet. And we are told in our formula and tables booklet that 1 mole of any gas is equal to 22.4 litres at STP, at standard temperature and pressure. 22.4 litres. And we're told in this question that indeed it's at STP. So we know 1 mole of any gas is equal to 22.4 litres. Well, we've got 0.01 moles of our carbon dioxide gas. So if we times both sides by 0.01, we will have 0.01 moles is equal to 22.4 litres times 0.01 is 0.224 litres. So let's just check what we did there. We had the number of moles of azorite. We used our molar ratio from our balanced chemical equation to find the number of moles of carbon dioxide. We used our molar volume from the formula and tables booklet, that 1 mole of any gas is equal to 22.4 litres. And we found the volume of carbon dioxide that was released. Now, really important note is not to get confused here with our molar volume at room temperature. Do not use this. So this is room temperature. At room temperature, 1 mole of any gas is equal to 24 litres. So be really careful what the question is asking you. If it's at standard temperature and pressure, 22.4 litres. If it's at room temperature, use 24 litres. So don't get confused between those two. Now the final question is, we are to suggest a way that further deterioration of the painting by this chemical reaction could be prevented or delayed. And they're giving us a whole 1 mark for this question. They're very generous. Well, this is something that you're not expected to know off by heart. This is something that you're expected to be able to interpret from your balanced chemical equation here. And we can see that we have our azorite and we have to add water to the azorite to get our malachite. So if we keep our painting away from water, it's going to delay the deterioration of our painting. So we can simply say that we'll keep this painting keep it away from water, or keep it in a low humidity environment. Or just keep it away from water. And that's the final part of that question.